A lot of the people that read about containers, they read the theoretical material. The developers now control the entire stack. Security is probably one of the most important things about software. And, developers can make mistakes. How do you make sure that everything is compliant and is as safe as possible? You'd rather know about a vulnerability as you check in your container or your code rather than wait for it to happen in production.
What's more important is the revolution of how software is built and who's building it.
Today's tools were not built for the CI/CD world.
Hi, I'm Guy Pojarny, CEO and co-founder of Sneak. And you're listening to The Secure Developer, a podcast about security for developers, covering security tools and practices you can and should adopt into your development workflow. The Secure Developer is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com. If you're interested in being a guest on this show, or if you would like to suggest a topic for us to discuss, find us on Twitter @TheSecureDev. So hi everybody and welcome back to The Secure Developer. Here today with us, we've got Ben Bernstein from Twistlock. Thanks for coming on the show, Ben.
Oh, thank you for inviting me.
I think maybe before we dig in and start talking about all sorts of things, container security and microservice security and the likes, maybe Ben, do you want to give a quick intro to yourself, your background, what do you do?
Sure. I've actually been developer throughout most of my career in Microsoft, from all places, working on different security suites and the OS security of Windows. And recently, me and another friend, we started Twistlock, which had to do about the change that is happening in the world of developers and how it actually affects the security world. And this is how Twistlock came into being.
Cool, yeah, and I think the container security space is hot and new, but also entirely imperative to the adoption of containers, which is growing probably faster than the security controls on it are.
Absolutely. And for us, it's really an opportunity. And we were pretty amazed with the reception of the concept that you just outlined, yeah.
Yeah. So I guess maybe to level set a little bit, right? We're talking containers and security, right? This is probably going to be a theme this episode. Can you give us a bit of a baseline about what should you care about, what should you think about when you think about security aspects of containers?
So it's really interesting because a lot of the people that read about containers, they read the theoretical material. They come to the conclusion that the most fundamental issue about containers is whether they're as secure as VMs or not, and whether you lose something between moving from VMs to containers. But that's not what I've seen in practice in all the customers that actually, and organizations that move to containers, and especially the enterprise one. And you must remember that the core thing about containers is the detachment of software from the actual physical or now virtual machine. So the interesting thing is not whether they're as secure as VMs, but rather how you could control the mass and the empowerment of developers to do so many things. The developers now control the entire stack. And just like with everything else in life, you need another safety measure, right? I mean, security is probably the most important thing or one of the most important things about software. And, developers can make mistakes. How do you make sure that everything is compliant and is as safe as possible? In the past, you had IT people. It will be their safety belt. Now you need sort of something else to help them.
Yeah, I guess the location of where some of these decisions are made change, right? And the hopefully outdated, but still probably very much alive in certain systems world, where in order to run something, you would have to ask InfoSec to provision a server or ask IT to provision a server, and that would require an InfoSec inspection. Then, it's not a great world in many ways, but in that world, at least there is that security inspection that just completely disappears in the world where, as a developer, you put in a Docker file and voila, the entire operating system just got stood up.
Absolutely. And here lies also the opportunity, because when you think about it, as a developer, you'd probably not want to wait until the IT person knocks down your door and says, what the hell you just did. What you'd like to do is to use the CI/CD tools in order to push things into some staging mechanism or something that reviews it and pushes back to you if there's any issue. And that's actually really a good opportunity for you as a developer to get the feedback right away. And so, in the past, a lot of things that used to be issues would only be discovered very late in the process, and then you have to you had to find out which developer did what and why. And here, once you do something that is wrong, this is an opportunity to actually push back things. But just like you said, you have to choose a different location to do these things. And the CI/CD tools would be probably the best location to give feedback to the developers about anything you can do. Because, for example, vulnerabilities, you'd rather know about a vulnerability as you check in your container or your code rather than wait for it to happen in production and it being picked up by some mechanism. So always closer to the developers, always have and always will make more sense.
Yeah, I definitely agree with that perspective. I think containers sort of do two or three things in the process. One is the technical one, which, as you pointed out, is not that important, around the fact that, technically your operating system is going to run under or within a container versus within a VM. And there was a lot of conversation in container security world earlier on about, was just shortcomings in the Docker engine. And, some of those are still there, but they're less interesting about whether, a container is isolated or not. They're interesting today, but like long term, they're a secondary. What's more important is the revolution of how software is built and who's building it, right? So maybe sort of splitting those in two a little bit. There's the technical aspect of it you mentioned right now, right? Or it's not that technical, but it's around how is the software being built. It's now built as part of a CI/CD process, and maybe we lost some security gate that we had before in asking the InfoSec person whether they can do it, but we've just gained access into this CI/CD world and this opportunity to run tests early on. So I guess we can have the whole thing be a net negative in terms of security if we don't capitalize on that opportunity, or we can turn it into an advantage if we do tap into it.
Absolutely. And it almost goes back to the question of tests and a lot of the other stuff. And you can look at some of the companies who have been doing it right, like Netflix and Google, and the way they did their CI/CD and the way they did their staging and their, chaos monkeys and all that kind of stuff. I mean, just trying to figure out about things as early as possible and doing it in an automated way is really important. So you must sort of develop new tools that don't exist today that enable you to do all of that, because today's tools were not built for the CI/CD world. They were not built in order for the security people to set the policy and then for that policy to be enforced in a dev-friendly way. So, when you're thinking about how you're going to build your dev to production environment, this is definitely something that you want to keep in mind.
Yeah, and I think the notion of how security tools were built for security audits more so than any sort of continuous testing is a bit of a recurring theme in the show here. We've had it come up several times because the tools were built for the present in which they're being used. And in fact, even today's present, right? The majority of security controls today happen outside of the container world and the continuous world. That's increasingly changing, but that's still the case. So you need tools that focus on the use case of building in that CI/CD, again, capitalizing on an opportunity because you just lost something, but you gained something all that much powerful if only you had sort of the tools to take action there.
Absolutely. Honestly, this is almost half the story. The other half is actually the fact that containers in themselves, the fact that they're minimalistic, the fact that they're immutable, the fact that they're more declarative, even let you eventually get to a situation where at runtime, you could get to even better indication of compromise and anomalies and better baselining based on machine learning. And a lot of the good things that security is about, but it's not I guess it doesn't have to do with the developer space, but I'm just saying because developers move to this, you actually get more information and you're able to protect them better at runtime. So not only do you get better feedback to the developers, eventually the security pros would also find this system more useful. So it's sort of a win-win.
Right. In this case, I would say that containers are just one manifestation of infrastructure as code. And infrastructure as code as a whole implies predictable hardware or predictable deployments, again, barring bugs. But it's predictable deployments, and therefore you can go on and you can check controls. Netflix actually have, I think it's called the conformity monkey as part of their CMN army, which goes off and lets you deploy stuff, I think as is. I'm not sure if the conformity monkey is a gate or not, but then it goes off and it randomly finds systems and it just checks to see whether they conform to what they should be conforming. So developers can go on and do whatever they please, but they may be caught if they've done something wrong by the conformity monkey. Again, giving them sometimes an opportunity, but also showing them the responsibility that they need to address that. And tools of that nature, they don't have to be containers, but they have to be in that context of infrastructure as code.
Absolutely. I actually had an interesting discussion with one of the people in Netflix, and they mentioned to me that they even have a new monkey that tests access control. So you don't typically think about that, but developers now have not only the power to create code and to create the entire stack, but there are some things that typically were taken care of by the IT people, and suddenly developers have full control over it, and you suddenly don't have the extra safety belt. And one of which is identity and how much privileges does your services have? Because you as a developer, and you're testing in some environment, you might create some kind of authentication and authorization policy, which is good for your environment, but maybe it's not good enough for production. So they actually have this monkey that tests least privileged user, and that's really, it's interesting that they came to this conclusion so early, because this is, they did it based on practice, because they saw that developers sometimes make mistakes, and you need some kind of again, staging tools, monkeys, to sort of check whether they did everything correctly or not.
So I guess trying to enumerate a few examples, just sort of give people some things to tee up. You're using, let's even focus on containers, right, as opposed to the broader concept of infrastructure as code. You need to test for something, have some security controls as part of your CI/CD process. We touched on two examples here. You can look for vulnerable artifacts in those containers you're deploying, and the notion of sort of least privileged user, so you can audit probably the user that systems are running with. What other examples do you encounter? What type of or you think that people should do?
Sure. So, the most common one, or the most basic one, would be a golden VM that used to be sort of a way for IT people to force certain OS hardening rules. And so anything you could imagine about OS hardening, simple example would be there shall be no SSH daemon in production, right? I mean, that's just one example. But anything that you'd expect the base OS to have, anything that, when I say base OS, I'm just thinking about the user mode, right? Because the kernel, the Linux kernel is shared with the host, but still there's so much damage you can do by accidentally slipping something into the OS layer that's not protective. And then you basically need to make sure that it conforms to certain standards. And then you go to stuff like devices, right? You could write something that, looks at some attached device for some reason. And as a security person, you probably want to limit these capabilities, because you in development, it made sense to you to attach this device, you probably don't want to attach any device in production, So a lot of these slips that could happen need to be actually checked before something is being put into production. On top of that, there's a whole, some specific to containers, something called the sys benchmark, which have to do on whether in the container you defined a user or did not define a user. And it's based on which version of Docker you used and whether you used certain restriction or you didn't. So honestly, even like the biggest experts could get something wrong, not to mention just, a standard user who's just trying to get around to writing a hello world program and may not have restricted everything that should be restricted. So the CIS benchmark has about, I think, 90 different things that could go wrong and you want to check for, ranging from the daemon configuration, the host configuration, the specific containers. So it's all over the place. It could be things that the developer did wrong or something that the DevOps or the IT person that set up the host on which the Docker is running has done wrong.
Yeah, those are really useful. We can throw a link to them in the show notes. The concept of enforcing or testing for some basically policy violations, right? Those that sometimes sounds like a heavy concept, but in fact, it's actually very, very straightforward to see that you're using the right operating system. And I can totally see that happening. In fact, I've sort of seen it happen even, personally. I have done it, which is, when you're local and you create a Docker file or you create some environment, your bias is to get it to work. And the inclination is to just add things. And then by the distance of time between the time you've just done that and you've made the decisions about whatever operating system, whatever you installed on it, and the time in which you commit that and have that deployed, there's a lag there. And during that time, you don't remember those decisions that you've made earlier on that you entirely intended to make temporary, except, nothing's more permanent than the temporary. So yes, those sound really useful. And there's also, I came across this interesting Dockerfile linter earlier on that does some of those components. We'll throw a link to that from the guys that Replicated. So you go on and, these are tools. Maybe this is the technical side of the fence, right? The tooling you can put and the audits or the checks that you can add as part of your CI/CD piece. I think the other part is the people piece, because what also shifts in what you've described of the process is it's not just the tests that get run, it's also the people that run them that change. It's not the InfoSec person that does whatever inspection on the check. It's the developer that is adding a test to the CI that does the inspection. How have you seen that interact? You work with, with all these companies, they're adding container security components. What do you see works from the interaction between the people coming in with the security inputs and the developers or DevOps teams that need to apply them?
So it's interesting because it's sort of bottom up. The whole approach to DevOps seems to revolve around smart people who own the dev space and then smart people who come from the ops space, and they typically work together in order to create some kind of a legitimate infrastructure on which the entire organization can follow. And so the end result is that the SecOps people, the security pros, they would like to set certain standards and have them being applied across, and they need the DevOps people to actually implement all the mechanisms. If you go back to how application security used to be in the older world, in the VM world, you always had the security ops people working with the networking guys in order to put in all kind of IPS, IDS mechanisms. So it's almost the same to some extent. They work with the DevOps people, but here the DevOps people have a lot more responsibility because they're dealing with a lot of delicate things such as the development process. So they need to be very professional about it. The toolings, all the tools are still new. There's a variety of things, so they need to be experts in that. And sometimes you get to a situation where you run into a security pro person who actually is so good that he learns about the development process, he learns about the CI/CD tools, and he's comfortable implementing some of these things himself. But that's kind of the exception rather than the rule.
Yeah, I think maybe one delta between the network ops people and the DevOps people is just the pace of change. The network world did not change faster than the security world, or in fact, probably the other way around, while the development world, especially in the sort of continuous versions of it, changes very, very quickly. So to an extent, I think you're entirely right. I entirely agree with the importance of having the security team and the development team, or the SecOps team and the DevOps team communicating. But I would also say that this is a case that resembles a little bit more DevOps, not just blurring, but entire elimination of the line almost between those components, where those teams work very, very closely and very much hand in hand. DevOps did not eliminate ops teams or make all developers ops experts. There are still people within the majority of companies that operate it that are predominantly dev or predominantly ops. It's just they're not 100% anymore. They're 5% of the other thing or 10% of the other thing. And either way, they're sort of a part of the same teams, cohorts, goals, and work together.
Absolutely. And it sort of even elevated the level of policies that the security people sort of put into the picture. Because in the past, the security people used to be involved in every little thing that the developers did before they actually put it into production. Now, it's no longer manageable because the scale is so big. So it actually forces the security people to think about this meta policy. There should be this and everything should be that, and apply it, because they can no longer go to every person who owns a microservice and ask him to describe in 10 pages what he's going to do, and then read these 10 pages, and the next day he's going to change it slightly. And so actually it sort of elevated their level of policy making, and also required them to get to understand the DevOps space much better in order to understand what they can and cannot do. So I absolutely agree with you.
Yeah, and that process has actually happened in the ops world, the notion of write it down and then write it down in code. Ops systems were also voodoo, sort of like, the flow of actions you might do during a security audit. They were just in somebody's head or they were written in some outdated document. And then as systems and the deployment of those systems became more automated and more touched, then those had to, first of all, be written down in code so that they'd be predictable and not go out of date because they represent what's on the system, and later on even be written down or edited by people that are not in ops. So I guess it's the same process that security needs to go through.
Absolutely, and we're actually taking advantage of that, like you pointed out. When we get to actually see what's running, you need to understand the full context. You need to understand the infrastructure that was there from the hardware all the way to the actual last bit of software configuration that you did. And like we said, you can't do it on a manual basis. So actually, infrastructure as code is actually very helpful in the process of protecting software all the way to runtime. So this is a blessing for the security world.
So these are really good topics. And when we talk about containers, we talked about both the security implications within the containers, thinking about what's in them and the fact that they get created differently. We talked about the opportunity to integrate testing and which tests you could do as part of the CI/CD process and the people that run them. Maybe one sort of last topic we can touch on, which is also kind of top of mind for many people, is not the containers themselves, but rather the microservice environment that they enable, right? Containers as a tool or as an opportunity offered us the opportunity to now deploy many, many, many different systems because it's that easy to create them and to create lightweight versions of them, eliciting this new microservice environment, right? Suddenly you have 100 servers, or maybe 100 is a little extreme, but 20 servers that perform the same action that a single server would have had before. That also introduces a whole bunch of security concerns, no?
Yes, absolutely. It does. And it goes back to our talk about the scale. And by the way, we've seen customers running it on hundreds of hosts. And we have some customers that plan to go to thousands. So absolutely. And you need to, when thinking about security, like we just said, you need to take into account the whole stack, but you also need to sort of think about the scheduling of these microservices in different environment. And on one hand, understand the full stack, which could mean different hosts. On the other hand, you need to understand the software piece, the specific container that you have. And if there's an issue with it, you want to flag it and say that this was the container. It wasn't the actual host. So it has to do with how you analyze threats. It has to do with how you report the threats. And it has to do, again, with the fact that you need to do everything automatically. So when something comes in, you need to analyze it automatically, because there could be thousands of the same container, or it could be 1,000 different ones, some of which could go up for 3 seconds and go down, and you'll never see them again. So everything needs to be automated. You need to think about scale, and you need to think about the different pieces, about the orchestration, and about this new stack that's not exactly just VMs and software which you run setup on. So it goes back to everything we've talked about, including the fact that these are microservices, which just make things sort of worse.
And I guess here there's also once again, the sort of the twofold version of it, right? When we talk about container security, one topic that often comes to mind when you run those containers is the fact that the containers run on a machine, and many cloud services like AWS would have their security policies around which network slots are open or which VPC you're a part of be an aspect of the machine while the containers run on those. And there's merit in them, again, in sort of security concerns and that run today, but there are once again shortcomings of the current ecosystem that's just adapting to it. Probably the bigger concern is in the changes that are here to stay, which is the fact that now you have all these different microservices, and to think about how they interact. What happens when one of those services misbehaves, what type of exceptions might bubble up to the user or to the outside organization? What type of network monitoring do you do to identify whether one of those components were compromised?
Actually, that's a huge opportunity again, because suddenly you got infrastructure as code, and suddenly you got the person who developed the service sort of imply to you, or even explicitly tell you, depending on whether he's talking about the inbound traffic or the outbound traffic, but he's sort of implying to you where each microservice might need to go. And then if you baseline it correctly and you understand the orchestration mechanism, then you have this new type of firewalling where you could, instead of just looking at static IP or, FQDNs, you suddenly understand this is a service. He's trying to do 1, 2, and 3. And if he's doing 4, which doesn't necessarily translates into a different IP. Maybe it's the same IP that you had before, but now it's a different host. Or maybe it's a new IP, but that's okay because it's talking to a microservice that it should talk to at this point. I mean, this actually presents a challenge and, again, an opportunity for tooling companies and firewalling companies and security companies to create a different type of firewall or a more elevated and container-friendly type of firewall.
Right. Each of these services now are much easier to understand. And if you understand them better because they're doing something much more pointed, then it's easier to differentiate right from wrong and be able to monitor it in the right way.
Absolutely. That's exactly what we think in Twistlock, and this is what we believe that the security world is actually going to revolve around that, about pure software and about understanding the developers when making the security decisions, because now developers are actually telling you more and you need to listen to that.
Yeah, I think that's maybe where the communication needs to be indeed kind of start going the other way, right? In the deployment process, the gates that have disappeared have now moved into the developer's hands. The developers now control what gets deployed, how it gets deployed, what tests run on it before it gets deployed. And that opportunity was lost in the gate, but was sort of gained now in running these far better tests in a far more continuous and efficient fashion. Now that that's deployed, security is never static. The fact you deployed something that you believed to be secure at the moment does not end your security work. Now you need to monitor these things in production, and that's where the information needs to come in the opposite direction. And again, like in DevOps, a lot of the concept is, if it moves, measure it. If it doesn't move, measure it in case it moves, right? And this notion of building operable software, you need to build, it's probably not a word, but securable software that has the right outputs to enable a security professional looking and probably monitoring the system in production to distinguish right from wrong, just like they would a service that is, just about to hit its capacity threshold and you're going to have an outage.
Absolutely. And I see it as almost a thread that goes from the dev through, baking to staging all the way to production, and it could go both ways. And this is really the biggest change. It's the change in development. It's the change in IT. It's the change in responsibilities. It's the change in security, and it's the whole opportunity for the ecosystem and specifically security. Absolutely.
So this is a really good conversation. Thanks again for sort of joining me in it. I think it's amazing to me every time how often you come back to the analogies between the DevOps world and the security evolution that needs to happen for us to sort of secure this world. Before we part, can I ask you, if you think about a development team or a DevOps team that is running right now and wants to improve their security posture, right? Wants to sort of up their game in terms of how they handle security, what's your sort of top tip, right? What's your the one thing you would suggest they focus on?
So if I had to say one thing, I would say that you should really start designing security as early in the process of moving to DevOps as possible, because you need to think about the tools and you want to put them in as soon as possible, because it's much harder to implement changes in the process later down the road. So it's kind of sound simple, but that's what all the people who implement best practices have done that we've seen so far.
That's a really sound advice. And also, I guess containers give you an opportunity to do that because you're probably restarting or rethinking some processes. So, that's your opportunity to build security in. Thanks a lot again, Ben, for joining us on the show.
Thank you for giving me this opportunity. I really appreciate it.
That's all we have time for today. If you'd like to come on as a guest on this show or want us to cover a specific topic, find us on Twitter @TheSecureDev. To learn more about Heavybeat, browse to heavybeat.com. You can find this podcast and many other great ones, as well as over 100 videos about building developer tooling companies, given by top experts in the field.